So you're building an AI rig, you're on a budget, and you've probably run into this exact problem. The RTX 3060 Ti versus the RTX 3070. I mean, they look so similar on paper, right? But there are a few key differences that could make or break your projects. Let's figure out which one is the right move for you. Look, you're ready to get your hands dirty with deep learning? That's awesome, but you need hardware that can actually keep up without totally emptying your wallet. That choice between the 3060 Ti and the 3070, it's a huge crossroads for a lot of people. And the right answer? Well, it really depends on what you plan to do with it. So here's how we're going to frame this showdown. The value king versus the powerhouse. One gives you this incredible bang for your buck, while the other just packs a little more of that raw computational muscle. Let's break down exactly what that means when you're actually training a model or generating images. Okay, so to really get what makes these cards tick, we have to start with what they have in common. And that's the absolute beast of an architecture they're both built on, NVIDIA's Ampere. What's really fascinating here is that both of these GPUs are basically cut from the same cloth, the GA104 chip. This means they share the same powerful DNA. We're talking doubled floating point performance, which is just a fancy way of saying how many calculations they can crunch at once. And most importantly, they both have those crucial third-gen tensor cores, which are like specialized little engines built specifically to speed up the complex math at the very heart of AI. And hey, don't just take my word for it. NVIDIA themselves were really clear about this massive leap, saying the new architecture delivers up to a 2x speedup. So yeah, this isn't some small incremental update. It's a genuine generational jump that makes a huge difference for deep learning on both of these cards. So they've got the same incredible DNA, but, and this is a big but, this is where their paths really diverge. It stops being about what they can do, and it becomes about how much they can do at once. Let's look at the raw core counts to see exactly what I mean. First up, the RTX 3060 Ti. It's packing 4,864 CUDA cores. Now, you can think of these as the general-purpose workhorses that are going to handle the bulk of your neural network calculations. That is a very, very solid number. But then you look at the RTX 3070 and, whoa, it jumps to 5,888 CUDA cores. That's more than 1,000 extra processors all working in parallel, and that directly translates to more raw, unadulterated processing power. So, when you put those numbers side by side, what does that actually mean? Well, the RTX 3070 is packing about 21% more CUDA cores, and you guessed it, 21% more of those specialized tensor cores. In the real world, that means faster model training and higher inference throughput. For the exact same job, the 3070 just gets it done quicker. Simple as that. Okay, so the 3070 has more cores, it's the clear winner, right? Case closed? Not so fast. When we look at the memory, there is a fascinating twist in this story that you absolutely need to know about. At first glance, looking at the standard versions, it's a dead heat. They both have 8 gigs of GDDR6 memory, they're both on a 256-bit bus, which means, yep, they have identical memory bandwidth, 448 gigabytes per second. No advantage for either card here. But, and this is where the story gets really fun, one of these cards got a little mid-cycle refresh. A quiet upgrade that gave it a pretty significant and kind of hidden advantage. A secret weapon, you could say. And here it is, the big twist. Some of the later models of the RTX 3060 Ti were quietly upgraded to much faster GDDR6X memory. This boosts its bandwidth to a massive 608 gigabytes per second, completely leapfrogging the RTX 3070. Now, this is a huge deal for any task that's constantly shuffling huge amounts of data around, like generating high-resolution images. That extra bandwidth can give you a really noticeable speedup. So we have more cores on one side and more potential memory bandwidth on the other. Okay, let's translate all these specs into what they actually mean for the projects you want to run day in and day out. Before we go any further, though, we gotta talk about the elephant in the room for both of these cards, that 8 gigabyte VRAM limit. I mean, in an age where AI models are getting bigger and bigger, is that still a workable amount of memory? So, is it enough? Well, the answer is a kind of complicated yes. For a lot of projects, like training computer vision models or fine-tuning language models that aren't gigantic, 8 gigs is totally fine. But for the really, really big models, you're going to have to be smart about it. That means using things like smaller batch sizes, or getting familiar with clever techniques like LoRa and QLoRa, which let you train these huge models without needing a supercomputer. All right, just so you have it all in one place, here's the full spec sheet side by side. You can see those key differences we've been talking about, the CUDA cores, the tensor cores, and of course that huge potential difference in memory bandwidths, all laid out right there. All right, we've laid out all the pieces of the puzzle. Now, let's put it all together into a really simple framework to help you make the final call, the best choice for your specific needs and your budget. You know, it really just boils down to this. Path 1, if your main goal is raw speed, if minimizing training time for compute-heavy tasks is your absolute #1 priority, then the RTX 3070's superior core count makes it your card. Path 2, however, if you're all about getting the absolute best value, especially if your work is sensitive to memory speed, like generating high-res images with stable diffusion, then a GDDR6X version of the RTX 3060 Ti is an incredible, incredible choice. Now, we've covered the big highlights today, but if you really want to get into the nitty-gritty with benchmarks and all the raw data, all the source material for this analysis comes from bestgpusforai.com. We've got the link for you right in the description below. And that really brings us to our final thought for the day. Both of these cards are fantastic, but they really highlight this growing tension, right? We've got AI models getting bigger and bigger, clashing with the VRAM we have available on consumer hardware. It really leaves you with a big question. How is this 8GB bottleneck going to shape the design of the next generation of GPUs for all of us? Thanks for tuning in.